not all shapes are obviously rectangles or triangles. We're sometimes presented with some fairly complex shapes that we're asked to work out the area of. But this is sometimes a little bit easier than it at first looks. This shape doesn't seem to fit any pattern of the regular shapes that we have been able to get formulae for. But if we look at it closely, we can see that it's actually made up of a number of simpler areas that we could work out. There's a trapezium at the top, there's a rectangle in the middle, and there's a semicircle at the bottom. And we've got enough information in terms of the lengths and widths of those things to work out all of the areas. So let's drop them back together. We'll colour them so that we can see the different bits, and then we'll work out the areas of the individual parts. So first of all, onto the semicircle at the bottom. The width of the whole of that shape is 8 centimetres, so the radius of the semicircle is going to be half of that, which is 4 centimetres. We know, because we've said it enough times and we've remembered it, that the area of a circle is pi r squared. So the area of a semicircle, half a circle, is half of pi r squared. So if we put our value of r into that equation, we get a value for the area of the semicircle of 25.1 centimetres squared. Okay, let's move on to the area of the rectangle. The area of a rectangle is probably the simplest one. It's the base times the height. The base of the rectangle is 8 centimetres, the height is 6 centimetres, so the area of that rectangle is 48 centimetres squared. Finally, we move on to the trapezium. The area of a trapezium is a half times the base plus the top, then times the height. So we've got the values for the base and the top are 8 and 4. We can put those into the formula and we get a value of 30 centimetres squared for the area of the trapezium. At this stage, many people lose marks because they forget that the actual question was, what's the area of the whole shape? So to get the area of the whole shape, we add those three together, 25.1 plus 48 plus 30, and that gives us 103.1 centimetres squared. So whilst that at the outset looked like a fairly complicated shape to work out the area of, once you divide it down into the individual parts, you can see that it's quite simple, as long as you have remembered the formulae for the areas of the individual shapes. Let's look at what on the face of it is a slightly harder area problem. Here it is. Well, that looks quite tricky, doesn't it? What we're going to do is exactly what we did before. We're going to break this shape into simpler shapes that we can work out the area of. There's a triangle at the top. There's a rectangle in the middle, but it's hidden behind a semicircle. So this is slightly different to the previous problem in that we've not got to add all of these together, but we've got to add together the triangle and the rectangle areas and then subtract the area of the semicircle. So the first task we have to do is to work out the areas of each of those three parts. Let's start with the triangle. We know that the area of a triangle is a half times the base times the height. The base of this triangle is 8 and the height is 6. So a half times 8 times 6 is equal to 24. So we have the area of the triangle equal to 24 centimetres squared. The rectangle is the simplest of the three areas. It's base times height. The slight difficulty here is that we are not given a value for the height, but we do know the value of the height of the whole shape is 15, and that the triangle takes up 6 of that. So the height of the rectangle is 15 minus 6, which is 9. So the area is 8 times 9, which is 72. We can move on now to the semicircle. The area of the semicircle, half pi r squared. R, again, in this case is 4. So we've got a half times pi times 4 squared, which is 25.1 centimetres squared. The total area, remember this time we have to subtract the area of the semicircle. The total area is 24 plus 72 minus 25.1, which gives us a total of 70.9 centimetres squared. As I'm sure you can imagine, there are an infinite number of complex shapes that we could make up using triangles and rectangles and trapezium and kites and circles, and we can subtract and add different parts of those. The trick for you is to recognize, when you're given a complex shape, what are the individual shapes that help make it up. Often a clue is whereabouts you've been given details of lengths and widths. In the example we've just looked at, you can see that we've been given the total height of 15 and we were given a height of 6 for the bit at the top. That gives you a hint that the bit at the top is separate, and it also gives you a hint of what the bit at the bottom looks like. So use this information. Use another piece of paper to cover up parts of the diagram so you can see the individual parts that it appears to be made up of. Once you have worked out what those individual parts are, write them down like we have done in this example, so that you can then write down the formulae for the areas of those individual parts. Do it bit by bit, and don't forget at the end you want to provide the area of the total shape, either by addition or subtraction, or a combination of both.